Hey guys, so this lesson was LP 3.3 on finding distances, and our learning target was I can find the distance between 2 points in a coordinate plane. So we reviewed what a coordinate plane was, and here's an example where we can see that there is an x-axis down here, our horizontal axis, and a y-axis, which is our vertical axis. And when we graph points on them, we call those points coordinates or ordered pairs. We can find distances between points on our graph. So we had been talking about the Pythagorean theorem recently, and we're really going to use that a lot in this lesson. So for example, if I'm trying to find the distance between points A and B, so that is this diagonal distance here from A to B. I can see that I don't actually know what that is, and some of you suggested like, oh, we could estimate or we could measure it with a ruler, but there's actually a more exact way that we can find an answer for that. And this calls back to when we were talking about driving distances versus flying distances. So really from point A to point B is like a flying distance. We're able to go directly there. Whereas if I were driving along like my roads from point A to B, I could kind of draw something like this, where I can see, okay, I could go north a block and then go east 5 blocks, and what I've actually created is a right triangle. And I know in this right triangle, I have a side length of 1, because we went up 1, and a side length of 5, because we went over 5. And we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, to solve for our missing side length. So in this one, our missing side length is the hypotenuse. So I would plug in 1 squared plus 5 squared equals c squared, and I can just square my values. So 1 squared is 1 plus 5 squared is 25, and this is equal to c squared, and we know we add those together. Oops. Give me 26, and I want to get c by itself, so I take the square root of both sides. So the square root of 26, I can plug this into my calculator, and I will get that c is about 5.1. So we found the pretty close to exact length between points A and B using a right triangle and the Pythagorean theorem. I could do the same thing with any other 2 points. So for example, if I wanted to find the distance from, let's say, A and D. So trying to find this diagonal distance here. So again, I'm going to create a right triangle, and to create that we can think about the driving distance that it would take for us to get from one point to the other. So if I wanted to go from D to A, I would drive my horizontal distance, which it looks like is 7, and my vertical distance, which is 4. And I can plug that into my Pythagorean theorem because those are like my legs, my A and my B. So I have 4 squared plus 7 squared equals c squared. And now the process is just the same. I'm going to square those values, add them together, which when I add those together I get 65. And then I can square root. And when I square root that on my calculator, I get that c is about 8.06. So there's that exact distance. Now we can also find easier distances too, of like if I wanted to find the distance from A to C, I don't need to make that more complicated than it is. I don't even need to make a right triangle because that's a direct distance, a vertical distance. And I can do the same with like horizontal distances. I can just count. That from A to C is 1, 2, 3, 4, 5, 6 units long. Okay, so really what you're doing to find the distance between 2 points on a coordinate plane is you're thinking to yourself, okay, here's my hypotenuse. I'm going to make a right triangle out of that. So I would maybe go down 2 over 7. There's my right triangle. And I'm just plugging those values into the Pythagorean theorem to solve for my diagonal distance or my hypotenuse. Hope that helped.